Hi, my name is Terry Liu, and this is my video for teaching assistant application. And first, let me give a brief introduction about myself. I graduated from Zhejiang University, and I'm currently a PhD student at ECE department. I'm interested in recommender system and web mining, and also have some related experience and skills in the same field. Today, I'm going to briefly introduce word embedding, which I think is a cornerstone of natural language processing. So the goal of word embedding is to learn a good vector from words. And at the very first beginning, we use bag of words model. For example, we will use a one-hot encoding to represent each word in sentence. Consider this example, we have a sentence, I love recommender system. And here we encode I into 1000, love to 0100. And since we only have 4 words, the vector is of the length 4. But there are some very serious problems with this method. Consider we have a corpus of 10,000 words, our vector size should be 10,000. And this is very computationally inefficient. And also we cannot compare the similarity between words because the cross product between every 2 vectors are always 0 because they are orthogonal. To solve this problem, people use different ways to do word embedding. And today I'm going to talk about word2vec, which learn a dense low dimension embedding. And let's look at some interesting property of word embedding. So the vector women minus the vector man is very similar to aunt minus uncle. So it learns the meaning of gender behind the word. And the idea of word2vec is actually very simple. The representation of a word can be denoted by its context. So if 2 words are very similar to each other, their context should be very similar. And so the word representation should be also very similar. And there are 2 versions of word2vec. We are only going to talk about Sable here. And in Sable, we take vector embedding of n words behind the target and n words after the target. So we use the surrounding words to predict the central word. And we don't care about the order of the surrounding words. Consider an example here. We have a sentence, the cat sat on floor. And we use window size 2. We use the central word set, and the surrounding word, the cat on floor, is used to predict the word set. And let's see how we do that. The input is actually like a one-hot encoding. Only the 1 here denotes cat, and the 1 in the 4th row denote on. And after that, the input neighbor will time a matrix and to get a dimension of the word embedding. And we'll also do some inverse transformation to let it go back to the dimension of the word size. So the matrix here is of the size v times n. V is the length of the vocabulary dictionary, and n is of the size of the word embedding. And the whole architecture is actually encoder-decoder architecture. And what we want to do here is we want to learn the W matrix and the W prime matrix. So after the learning process, this is the lookup table we obtain. And here I need to mention that the word matrix times the row is what we get here is we actually select the column that contains the embedding of cat. And in this example, it gets the embedding of on, and we will do an average and go through the inverse transformation and go through a softmax, and we will get the probability distribution we want. And after we get this y prime, which is the predicted distribution of the output, we will compare it with the ground truth y, and we can use cross entropy to calculate the loss of the 2 distribution. Ideally, this should be very close to each other, and we will do back propagation to optimize the matrix W. So after we finish our training, the W matrix is the word representation we want. And there are also some other techniques like negative sampling and hierarchy softmax for training the word2vec. Thank you for listening.